On January 14th of 2026, the U.S. Geological Survey posted a statement regarding the Pavlof Volcano in Alaska. To very briefly paraphrase what they said, new volcanic unrest was detected at this volcano, which was primarily defined by increased seismic activity, with similar activity sometimes but not always directly preceding some of its historical eruptions. However, Pavlov doesn't always provide much warning before it erupts, meaning based on recent activity, this volcano could technically soon erupt with little or no warning, although this is far from a guarantee of happening. As a result, despite the lack of direct evidence for any new shallow magma, Pavlov's alert level was raised from green to yellow. For reference, the Pavlov Stratovolcano is located on the Alaska Peninsula, specifically 592 miles southwest of Anchorage. There, its glacier-covered edifice rises from its base at essentially sea level to an altitude of 8,261 feet or 2,518 meters. It is bordered by the neighboring Pavlov sister stratovolcano to the northeast and the cones and caldera of the Emmons Lake caldera to the southwest. Yet, if we look around, there is no obvious evidence of human habitation, with the closest signs of human life being 30 miles to the southwest at the town of King Cove. So, if no one lives close enough to be directly affected by lava flows or pyroclastic flows, why exactly are we discussing this particular volcano? Two reasons: air traffic routes and scientific interest. Pavlov's location places it in the middle of a major commercial airline route, so whenever it explosively erupts, its ash-filled eruption column has the potential to disrupt or even cause some flights to be cancelled. For example, on June 3rd and 4th, 2014, its eruption led to the cancellation of approximately a dozen flights, while a separate, even larger eruption led to around 100 flights being cancelled between March 27th and 29th, 2016. And since 1800, Pavlov has been the single most active volcano in Alaska and the second most active in the entire United States, only falling behind Hawaii's Kilauea volcano. However, unlike Kilauea, Pavlov's eruptions are not primarily effusive, instead being moderately explosive to highly explosive. Pavlov's typical eruption style is volcanian, although it sometimes produces more ash-rich Strombolian eruptions which feed lava flows. Some large eruptions have occurred in the past, but this volcano's explosivity index in distinct eruptions has ranged from a 1 to a 4. Regardless, Pavlov provides the most frequent example of explosive volcanic activity in the entire United States, being great for scientists to study. Pavlov's recent increased rate of earthquakes are primarily occurring 6 miles east of its summit, and while these, in my opinion, are more likely to represent the motion of volcanotectonic faults related to possible changing strain at the volcano, they could also be associated with magma rising a bit further downslope east of Pavlov's summit than is typical. However, it was specifically the increase of long-period earthquakes that began at 12:45 a.m. on January 14th that was the main driver behind the increase in Pavlov's alert level. These long-period earthquakes, per a direct quote from the U.S. Geological Survey, are not caused by brittle failure, but rather are thought to be caused by fluids moving through cracks beneath the ground. These fluids can be hydrothermal, water, or magma. If these quakes are indeed caused by magma, Pavlov could potentially begin its first eruption in 4 years sometime this month. As for nearby towns and settlements within a 100-mile radius, there is the potential for trees to light ash to fall were an eruption of Pavlov to take place. Pavlov's eruptions can last anywhere from less than 24 hours to more than a year in length. Stay tuned for more updates. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.